So we're looking at number 5 now, and we have a couple congruency statements. We have SU congruent to line segment LR. We have TU congruent to LN. I'm going to go ahead and put them here, okay. And my reason is going to be given. Now, what's my first step in completing these proofs? It's to take any congruency statements and turn them into equations using definition of congruent segments. And so that's what I'm going to do here. I'm going to turn these two statements into equations. So now the line above it goes away. It's measure SU is equal to measure LR. And then I also have measure TU is equal to measure LN. The lines go away above it. Okay? Now, what are we going to do? Well, the next step in writing the proof is if midpoint is given, you use definition of midpoint to create more equations. Well, is midpoint given? Right? If midpoint was given, you would say it would have here T is a midpoint or N is a midpoint. That midpoint is not given, so we skip that step. What's the next step? Is we now look at the figure, and if we're given 3 points on a line, we use seg-add-pos to create more equations. Seg-add-pos lets you say first part of the segment plus second part of the segment equals the whole segment. So let's go ahead and look at our figure now. Do we have 3 points on a line? Yes, we do. So what's the equation we can create? First part ST plus second part TU is equal to the whole part SU. And hey, look, we have another set of 3 points on a line. So we can apply seg-add-pos again. ln plus nr is equal to lr. And that's what we do here for C. This is going to be seg-add-pos. Next, what are we going to do? We're done with using seg-add-pos. What's the next step in writing a proof? Use substitution to get to the proof statement. Use substitution to get to the proof statement. So we're looking at these equations. We have 4 of them. We have this one, this one, this one, and that one. We got 4 of them. So can we substitute to get to the proof? Well, what can we substitute where? Right? Well, what we can do is we could take this expression here on the right side of the equal sign and put it in the place of SU. So do you see SU anywhere in the other 3 equations? Do you see SU here in this equation? No. Do you see SU in this equation? No. Do you see SU in that equation? Yes, you do. So I'm going to take this expression, I'm going to put it right there in the place of the SU. Substitute. Then I'm taking this expression and I'm going to put him in the place wherever I see LR. Do I see LR in this equation? No. Do I see LR in this equation? No. Do I see LR in this equation? Yes, he's right there. So I'm taking this expression and I'm going to substitute him in for LR right there. And that's how I get this expression, this equation here. Okay, that's substitution. All right, so now what do we need to do? Well, we're trying to get ST is equal to NR. We're trying to get ST is equal to NR. We need the TU and the LN to go away, right? And they would be able to go away if they were the same expression. If I could turn that TU into LN, then it'd be easy to make them go away because then I could just subtract ln from both sides of the equation. But the only way to turn this tu into ln is if I have an equation that says tu is equal to ln. Do I have that anywhere? Right? I have it. It's right here. Tu equal ln. So that means I'm going to take this ln and I'm going to put him in the place of tu right there. Okay, taking this ln and putting him right there, that is substitution. You see that? So I'm taking that tu, I'm replacing him with ln, substitution, using this equation here. Okay, so now that we're here, well, we want the ln to go away, so we subtract on both sides ln. That's subtraction property. After that, now this gets replaced with 0, and this also gets replaced with 0. Right? So we're left with ST is equal to NR. Right? What are we doing here? We are replacing this expression with what it's equal to, 0. We're replacing this expression with what he's equal to, 0. That's substitution. Lastly, we're turning the equation into congruency statement. That's def of congruence. Def of congruence lets us go from equation to congruency statement, or from congruency statement to equation, like we did up here. Congruency statement to equation. Definitions let you go both ways, and we're done.